And we're back looking at chi-squared test again today. This one we are looking at is the third and final type of chi-squared test that we are going to look at is the chi-squared test for homogeneity. We'll go over what homogeneity means in just a second. And we'll look at just one example instead of two because I'm trying to make them shorter here for you guys. All right, so the test for homogeneity. So homo means same. Geneity means, I guess we could say ness. Sameness is what we're looking at. Test for sameness. Are two samples the same distribution? All right, and we will always be looking at two or more samples when we're doing homogeneity. So if you have more than one sample, we're definitely means homogeneity is your guy. All right, so it's a test to compare the distribution of a single categorical variable across multiple populations or treatments. All right, so we could look at like how Americans feel about something versus how Germans feel about something, how men and how women feel about something. But we had to sample a sample of men and sample of women, different than last time, but two separate samples. All right, so our null hypothesis is that there is no difference. Our alternative hypothesis is that there is a difference. So alternative A, and again, we're going just ho no, easy to remember. State your alpha value. It's the test for homogeneity, and the reason we know that it's just because we have two samples. If you're not sure about the difference between homogeneity and association, you can just write chi-squared test, and most of the time they will still mark you correct. You need independent random samples, so there should be two or more samples here. Your large counts, your expected counts need to be greater than or equal to 5, just like before. It's calculated the same way, row total times column total over table total, or you can have the calculator do it and then write them down afterwards. Independence. Our n should be less than 10% of the population, just like always. Everything else is calculated exactly the same, including the degrees of freedom. The number of rows minus 1 times the number of columns minus 1. And we need to make sure we write that down, as well as write down our p-value and whatever our chi-squared value is. And then our conclusion is done the same way. If p is low, reject the ho, and we write a sentence about whether or not there is a difference, or we have evidence for that difference. All right, so here is our example. The gender of an interviewer doesn't matter. So interviewers asked two random samples of 50 males. So we're only interviewing men. Would you vote for a female president? And the results are listed below. One sample was interviewed by a female and the other was interviewed by a male. Is there significant evidence that the gender of the interviewer leads to different answers? All right, so we have two samples. All right. That means we're doing the chi-squared test for homogeneity. Let's see if I can just fit it over here. So this is the chi-squared test for homogeneity. All right, so we want to know, do these samples have the same response, homogeneity? All right, so we want to write our null hypothesis, and we're looking to see is there a difference between what people say based on their gender. So ho no, so was there is no difference in responses based on the gender of the interviewer. That's what's being changed. And then the ha would be that there is a difference. So we'd say there is a difference in responses based on the gender of the interviewer. All right, and they didn't give us any alpha, so we'll go with 0.05. They often don't for these chi-squareds, so 0.05 is pretty common. All right, let's see. These probably are random samples. Yep, we said it right there. So we have two independent random samples. And let's see, the expected counts, we're going to need to check those. They need to be greater than or equal to 5, so don't forget to go back to the expected counts. I'm going to write myself a note down here so I remember once I get back to the conclusion to go back and do the expected counts. All right, and independence. So we interviewed a total of 100 people, so that means our N is 100, which is definitely less than 10% of all, and we were just interviewing all men, so males in the US. There we go. All right, on our calculator, it is the chi-squared test, the same one we did before because it works the exact same way as the other test does. All right, so the numbers that we're going to have to put in our matrix, again, we leave off the totals, but it's this 3 by 2 matrix here. Oh, there we go. So let's see. Oh, I turned off again. Second matrix, edit. We'll just go into A. And it's 3 by 2 already set on mine. So let's see, we've got 30, enter. And it goes over, so 39. And then 8. And then 3. Oh, that one's kind of low. Then 12. And then 8. All right, so that's all of our numbers. They match. Yep, those match these. Okay. Now, 3's not bigger than 5, but this is an observed count and not an expected count. We don't care about the observed. We care about the expected. All right, so let's quit that. We'll go over to stat, test, chi-squared test. I'm just going to go up from the bottom. There it is, chi-squared test, option C. All right, A is our observed, our expected. He's going to calculate for us. And there we go. Chi-squared is 4.2, P is 0.12, and our degrees of freedom is 2. So our chi-squared is 4.4. Our P value is going to round to 0.12, and our degrees of freedom was 3 by 2, so that's 3 minus 1 times 2 minus 1, so 2 times 1 is 2. All right, write those all down right. 4.2, not 4.4. Actually, it's 4.24. There we go. Fixed it. Looks perfect. All right, so now, again, there's our P, there's our alpha. So since, oh, I almost forgot it again, but look, I saw this now. I saw this, so I need to go back and put in my expected counts. So before I forget, second matrix, edit, and let's check out B and look at our expected counts. There they are. Oh, that one's 5.5. Good. So 34.5 for both of them on top. And then the next row, both of them are 5.5, and then both of them are 10. And then 10, 10. And then each of those is definitely greater than or equal to 5. Yay, it checks out. Now I can conclude. Since the p-value equals 0.12 is greater than 0.05, which is my alpha, we failed to reject the null hypothesis. In other words, we do not have significant evidence that, and let's see, what are we talking about? There is a difference. So we do not have significant evidence that there is a difference. I'm just going to write exactly what's written here. A difference in responses based on the gender of the interviewer. Ta-da, done. All right, so I remembered to go back. Yay. And I probably need to label this. There we go. Expected counts. I drew an arrow. That'll work. All right, so that's how we do a chi-squared test for homogeneity. And let's see, I think that's, all right. So other times when we would use homogeneity. So if we have a sample in the US versus a sample in Canada or a sample in any other nationality, we want to compare different nationalities, how they respond to things, that would be test for homogeneity. If we want to look at deaf people versus blind people, homogeneity. A sample of teenagers versus a sample of senior citizens. Is this one on? These ones look rather tech savvy. Yeah. Of course, that one's knitting. And a sample of dog owners versus a sample of people without dogs. We would sample at like a pet, like a vet versus going around and sampling, I don't know, somewhere that people don't have animals or not allowed to have animals. All right. And that could be uses of homogeneity. So 2 or more separate samples that we're looking at here. All right. So that is how we do the chi-squared test for homogeneity. I kept it shorter this time, like I said I would. Next one, we're going to practice telling the difference between them.